Factors affecting the resistance. Okay, let's just talk about them. Hey, what is up everybody? This is Divyansh and welcome to my channel Learnium, where we learn and discuss with a lot of fun. Well, this is our next part of our learning journey of electricity. Okay, so I would like to begin this with a question. Okay, so here I have one USB with me. Okay, so I have one more. So here is our second USB. Now we can assume that both of them are made up of same material, like because most of the wires are made up of copper. So we are assuming that both are made up of copper, but the only difference between them is that this is of much more length, like the difference is of length. This have more length and this is much shorter. So you can see the difference in their lengths. Okay, now my question is that which of them will have more resistance? Like which of them will provide more resistance? Will resistance is going to be same in both the cases, or it's going to be different? Try to think about it, and I will also answer this question at the end of this video, right? So now with that, let's talk about resistance first. Okay, so tell me, what is resistance? Very easy. So we know that electrons move through a conductor. Now when electrons move, like they move completely in random directions, and during that they hit each other and they also hit with the walls of the conductor, and that simply is resistance, right? Now resistance is denoted by R and its unit is ohm, right? And from Ohm's law we know that V is equals to IR, like we learned that in our previous video of this series. Okay, so now I would directly like to jump on giving you an analogy on the factors which affect the resistance. Okay, so analogy number 1. Think about a race, a Olympic race. Okay, so here we have 16 athletes who gonna run in this race, and for them we have 16 lanes, right? So one lane for one athlete. But let's do something different here. So instead of 16 lanes, let's make it 8 lanes. Hey, so it means that 2 athletes are gonna run on one lane. Okay, that's gonna be crazy. Okay, so now let's make everything ready. Now we are going to begin the race in the count of 3. So 3, 2, 1, and the race begins. And here you can see the race is full of chaos, right? So here what's gonna happen? The athletes gonna hit each other. Why? Because there's not enough space to run properly, right? So at the end, this will affect everyone's performance. No one would be able to run properly. So this was just an analogy. Now we have to relate this with electricity. So the lane on which athletes were running, that racing track, is our conductor, right? And those athletes are the electrons. Okay, so what we did was that we reduced the cross-sectional area of the conductor, right? The area on which electrons were flowing, that was the cross-sectional area, and we decreased it. And after that, what happened? Yes, the athletes or the electrons now were hitting each other even more. It means that resistance has increased. So finally from this, what we can say? When we decrease the cross-sectional area, the resistance will increase. It means that they are inversely proportional to each other. So we can say that R is inversely proportional to the cross-sectional area. It simply means that when one increases, the other one decreases. Okay, so that was the first equation or the first thing that we saw here. Now let's talk about analogy number 2. Okay, so again we have the same Olympic race, But now one thing we are going to change. So let's assume that our initial race was of just 100 meter. So athletes gonna hit each other, and when they will reach at 100 meter, the race gonna end, right? But now let's make it 800 meter race. So now from 100, the race is going to be 800 meter. So what we can say, that now the athletes gonna hit each other for a longer period of time. Now they are going to hit each other for 800 meters. So finally what we can say. So now again it's time to relate this with electricity. So we can say that when we increase the length of the conductor, the resistance also increases. So R is directly proportional to length. Okay, so if one increases, the other one will also increase. That's what directly proportional means. Okay, so here we have seen two things. Now let's just try to mix both of them together. So if we were to bring them together, what we can see, yes, R is proportional to L by A. A resistance is directly proportional to L and inversely proportional to A. Okay, so now I hope that you have understood that. Now you tell me that, now we are going back to our question, right? So again we have two USBs. Now you tell me which of it will have more resistance. And one thing we have to keep in mind, that both of them are made up of same material. Okay, now let's talk about the answer of this question. So here you can see that their cross-sectional area is almost same. So one thing is clear, that their cross-sectional area is same. You can see it here. Now the difference is in length. So what we have seen just before, we know that resistance is directly proportional to the length. So it means that if length increases, the resistance also increase. So here we have a very clear answer, that this will provide more resistance compared to this one, right? So from this one is a better option if you want to charge your mobile phone, because this will provide less resistance because it is shorter compared to this one. So our winner, or the correct answer for this question, is the wire or the USB with small length. Okay, so I am hoping that you are enjoying learning this way. Okay, so once we are done with all of them, now one last analogy I am going to give you, but that's a funny one. Okay, so now again we are going to talk about an Olympic race, but now let's say that the temperature has suddenly increased. Like the temperature is right now 50 degrees Celsius. Hey, what is going to happen right now? So you can imagine yourself in that condition. Now in that case, will you be able to run properly? Will you be able to give your best performance? Right? You can imagine your hands, legs, or even your face, like a lot of sunlight and heat is going to be there. So finally our answer is going to be no. We definitely won't be able to give our best there. So from this what we can say, that temperature will lead in the increase of resistance. Right, so this was also an analogy that we have to keep in mind. Okay, don't try to relate this completely. So here we have that temperature and resistance are directly proportional to each other. Okay, so till now we have almost finished the factors which affect the resistance, but one thing is left. Okay, so before going directly into that, I want you to listen to this. So you all will agree with this. So let's say that we have some apples here. Okay, so the total cost is going to be directly proportional to the number of apples, right? If you increase the number of apples, the cost will definitely increase, right? So that's what we all will agree with. Okay, but now there is one proportional sign. So that is what I am trying to explain you. Now here the cost of apple would be equal to some constant multiplied by the number of apples, and that constant is going to be, can you tell me the answer? Yes, that constant is the cost of each apple, right? So the total cost is the cost of each apple multiplied by number of apples. So here the only thing I am trying to explain is that when we replace the proportional sign with the equal to sign, there will come a constant, and that is what we are going to do in our relationship between the factors which affect the resistance. So here let's go back to this one that we have already seen. Now here also we can see that there is one proportional sign. Now let's try to remove this. So what we will get, R is equals to some constant multiplied by L by A, right? Now that constant is resistivity. And now if you are wondering, hey, what is resistivity? Well, don't worry, I will cover that in our next video. But for right now, I would like to tell you that resistivity is denoted by a Greek letter rho, like it looks somewhat like a letter P from our English alphabets. And one more thing we can do here, that instead of writing their symbols, we can write the units here. So we have R is equals to rho into L by A. Now let's write the units here. So we have 1 ohm equals to rho multiplied by meter square. Okay, now let's rearrange the terms here. So what we will get? Yes, rho is equals to, yes, ohm multiplied by meter square by meter. And as you can see that those meter will get cut out. So finally we have the unit of rho as ohm meter. So that's it for this video. We have covered about the resistance or the factors which affect the resistance, and I have given you the introduction of resistivity. We'll cover more about it in our next video, right? So that's it. I hope that you understood this. If you really did, then don't forget to hit the like button and please subscribe to my channel for such more informative videos. I will meet you in our next video. Till then, thank you very much for watching.